Geometry, Notes on Rotation, Examples 3 and 4. We recall that we begin with a rotation of 180 degrees. So when we rotate a point AB 180 degrees, it has to be the same distance from the center. So if this is AB, then 180 degrees away will be negative A, negative B. Same distance, 180 degrees. That helps us with example 3. Sketch the image of the given polygon, the triangle, after each rotation around the origin. 90 and 180. Well, we begin with the 180 degree rotation because it is so much easier to see that. For example, from point D, from the center to D, we know 180 degrees is going to be the same distance in the other direction. So where D is 2, 6, D double prime will be negative 2, negative 6. Negative 2, negative 6. D double prime. F, 180 degrees from plus 3 will go to minus 3. And E, instead of being six, 3, will be negative 6, negative 3. We remember, of course, that a straight angle or a linear pair measures 180 degrees. So what we have is D double prime, F double prime, and E double prime. Our triangle will look like this. On your notes, you need to be filling this in. So if you're not doing that, please take a moment now and do that better. Okay, our original triangle is D, 2, 6, E, 6, 3, and F, 3, 0. D double prime is negative 2, negative 6. E double prime is negative 6, negative 3. And F double prime is negative 3, 0. Good. That is this triangle here. Now we know that a rotation is a set of points around a fixed space. So if this is a linear pair, if this is a line segment, what we need is perpendicular to this. Why do we need perpendicular? Because perpendicular is a 90-degree angle. So if, for example, we're going from 2, 6, we need a distance 2, 6. Well, 2, 6 is certainly not going to do it. So D prime will be -6, +2. The same distance from the center. E then, well, this is 6 and 3, so E has to be -3, 6. And 90 degrees from F has to be here. This is a right angle. This is the same distance from the origin. This is the same distance from the origin, and so is this. Only it's 90 degrees instead of 180. So this is D prime, this is F prime, and this is E prime. Let's see what we have here now. D prime is -6, 2. E prime is -3, 6, and F prime is 0, 3. Good for us. Let's do example 4. This one is a little more fun. Name the image of each triangle after the rotation around the origin. Rotate A, B, C 90 degrees. I don't want to do that. I want to rotate D, E, F 180 degrees because those are so much easier to see. D, E, F 180 degrees. So if D, for example, is -2, -1, then 180 degrees from that has to be -2, -1, DEF 180 degrees has to be D maps to J, and if the vertex of if D is -2, -1, D maps to J, we're looking for 180 degrees. The distance from the center to F is this far. So if I extend it in the other direction, I run into L. So if I'm rotating DEF 180 degrees, F maps to L, and the coordinates of L are 1, -4. That means that F has to be -1, +4. And here we have F, -1, +4. So our middle triangle must be K. Now if I'm rotating GHI 180 degrees, I'm rotating GHI 180 degrees, then H, for example, from H to the center is some distance, so I extend it, and oh look, H maps to B. So if H maps to B and B is 1, 4, then H is -1, -4. And H maps to B. I maps to C, so G must map to A. Now we're rotating ABC 90 degrees. So if we're rotating ABC 90 degrees, then C is going to map to F, because we need something that is the same distance from the origin to C, and we can see we have a little right angle here. C maps to F, B is going to map to E, and we can see that it does because here's another right angle. B maps to E, and A maps to D. Well, now wait. If D is -2, -1, then A had to be -1, 2. A is -1, 2. And if we're going to map JKL 270, well, here is 1, here is 2, here is 3. L is 1, -4. So there's the first one. Here's the second. Here's the third. One, two, three. K is going to map to H. L, let's see, we have 1, -4. I think a good way to do this is here to here is 180 degrees. So here to here is H I G. We may want to double check that. And we will work on this some more tomorrow in class. By the way, I am going to Meyerson Center on Saturday night to hear the Dallas Symphony Orchestra. Rotations take time and patience. They're much easier on a grid. The problems here are harder than the problems we will have on the test. We're going to be just fine.